Let me define the problem space clearly. If you cannot track an agent's path, you cannot secure it, you cannot audit it, and frankly, your CFO is not going to sign off on a budget which has no ceiling. If you have been working with agents or LLMs, you know that letting an LLM run wild in a dev test or a sandbox environment is as stable as hiring a genius intern who refuses to follow manuals. The POCs look brilliant on week one, but when the agent hits an edge case, let's say a tool has changed, then it does not know what to do. It goes into a loop. Meanwhile, your API bills are skyrocketing, as well as if those agents were connected to data systems, then the data is a mess also. Now the conversations in the industry are shifting from how smart an agent is to how predictable the trajectory is. The whole of today's SaaS economics is built on predictability. Today, I want to show you why we are moving away from completely autonomous agents to deterministically orchestrated agents. I want to add a caveat to that. Making an agentic architecture predictable is the path to go until the chips which does model inferencing, so the NVIDIA's GPUs, AWS Trainium, Microsoft Maya chips become cheaper. And that's the future that we are moving towards, that those chips are gonna make inferencing much cheaper. Until we reach that stage, the FinOps part of AI mandates that we move to a more predictable system where we can track costs, where we can audit, where we can secure that trajectory. Okay, just wanted to leave that caveat over here. The way an agent works is you give it a goal and give it access to tools. Also connect it to your RAG systems, and maybe there's also memory associated with that agent. And let's say to achieve a goal, the best path is call tool 1, get the result, and then call tool 5. Now, if the agent takes a path that it first calls tool 1 and then goes to tool 3, then goes to tool 10, and then it lands in tool 5 and realizes, oh yeah, okay, I have achieved my objective, that is an inefficient path to follow.
Instead of one model doing all the work, we will decouple thinking from doing. This is often called the Planner-Executor-Supervisor pattern. In this, there will be a high reasoning model like GPT-5 or a Claude 4 class of models who will maintain a global state machine and orchestrate tool calls. Then there will be execution models, which are smaller domain-specific models, more like worker nodes. And why do we bother with all this complexity? Because more often than not, this pattern leads to a better cost per accepted outcome. Using cheaper models at focused places leads to better success rates than using premium models all throughout.
We are at a point where Cloud 3.0 is maturing, and this channel is my public notebook for documenting the shifts in cloud and AI. So if you are a lead architect or a software engineer, senior principal, software engineer, and you would like to be on top of things without all the marketing fluff, please consider joining this peer group by subscribing to the channel. The key takeaway here is decoupling of duties. Your planner model or your supervisor model will be a bigger model and they have better reasoning capabilities. These models will be setting the direction of execution. But your execution models, they would be smaller, cheaper, domain-specific models. These models are also fast because their worldview is limited to your own dataset. A domain-specific small language model trained on your own data is inherently more predictable than a general purpose model. It just doesn't have the worldview to hallucinate, and that limits the blast radius of a compromised or drifting agent. Engineering for predictability is not just about cost. This is the only way to scale. See you in the next video.